The purpose of this tutorial is to make sure we know the most efficient ways to calculate the expected values and standard deviations of probability distributions using our calculators, because it just saves a lot of time. We're also going to review how to look at a probability histogram to visualize your data. So step one, you got to put your data into lists. So in my calculator, I have set up list one is the data values or the X values. List 2 is the probabilities from the first distribution, and list 3 is the probabilities from the second distribution. Let's first just get a look at these two different graphs. To do that, go into your stat plot, second y equals. Once there, you do want to turn on a plot. Make sure to set to histogram. For the X list, that's going to be your list of possible outcomes. So for us, that is L1. But we are now also going to put something in the frequency list. I want to have my bars' heights be determined by their probabilities. For the first class, that was list 2. Now, the drawback here is that if you do a zoom 9, it's not going to give you the fit you want. Let me clear that out real quick. It groups things together in a way that is not helpful. I want to have my groups be specified the way they were in the table. So we just need to set our window custom. Let's go from the low end of 60, and since our numbers were 10 apart, I want to go all the way up to 110. That's because my last group starts at 100, but is going to keep going for 10 units further. Set the bin width at 10. The Y's we're also going to need to set ourselves. Now, the highest probability this first time was 0.2. So your Y maximum has to be at least that high. I'm going to recommend, let's go all the way up to 0.8. And the reason I choose 0.8 is that when you set the Y minimum, to make it look good, you typically want to have it be negative your highest Y maximum divided by 4. So 0.8 divides nicely by 4. And so set this at negative 0.2. Your Y scale doesn't make any difference. I'm just going to set it at 0.1. That's how often it puts a mark on the vertical axis. And then don't redo a zoom 9 or it'll undo all the work we just did. Just take a look at a graph. And what we see is that our 60%, 70s, 80s, 90s, and 100s, they're all equally likely. They happen the same amount of the time. Let's take a look at the second class. We've done all the hard work. All you need to do this time is change your frequency list to L3. Go back to your graph, and we can see that, okay, in this class, we didn't have as many very low or very high scores, and we had more concentrated scores in the middle. Let's think about how this impacts spread. They look to be both centered about the same place, so the expected values should be similar, but the spreads should not. The first one that was uniformly distributed, more spread out. These are more concentrated toward the center and should therefore likely have a lower standard deviation. Now let's do that actual calculation. The visualization was to help us get a sense of what's coming. Now let's get the numbers. Go into Stat, Calculate, one variable stats. So as far as what goes in, we want to put in our data list, L1, and we're also this time going to put in a frequency list. This is what weights our data appropriately. So for the first class, those are in L2, calculate, and right there you go. First one is your expected value, and then down here, the sigma x is your standard deviation. So it does all the calculations you would do by hand, it just does them much more quickly. So on average, we would expect a score to be about 80. Not all the scores are 80. Typically, how far away from that 80 are they? About 14.1. Now, our guess is that for the next class, this standard deviation number should be smaller. The scores were a little bit more concentrated in the center. Let's see if that actually happens. Let's do, again, stat, calc, one variable stats. This time, change your frequency list to the second set of probabilities. Okay, expected value is the same. They were both centered at 80. But for the standard deviation, sure enough, it's a little bit smaller. That's because with more scores in the center, you have less variability overall. It's more likely that we are close to that expected value in the middle. So one last recap to wrap things up. When you want to do the expected value and standard deviation of a probability distribution that came from a table, put it in as lists. And when you do your calculation, have your data values, your outcomes to the experiment be the list one, the list data, and then have your probabilities be the frequency list. You should be good to go.